Dear aspirants, as you know, last week we discussed about how water is formed, formation of water by different methods. Okay, so in this, first method is by burning of hydrogen in air. Okay, last week we discussed already. I'm just briefing you. In second, we burn hydrocarbons in air. In third reaction, reduction of metallic oxide by hydrogen. Then during the process of respiration also uh, water is formed. So these are the mainly four methods for formation of water. Now today we will discuss something about first effect of temperature and pressure on solubility of gases. Okay, so as you know that the solubility of gases in a liquid decreases with rise in temperature and vice versa. Okay, simple example is that as the temperature of liquid increases, solubility of gases would be decreased. Okay, suppose there is a vacuum. Okay, there is a glass or anything. If you boil this water, okay, if you boil this water, the gases dissolve in it start to evaporate from it. Okay, so their solubility will be decrease with the increase in temperature. Okay, and vice versa. If there is decrease in temperature, their solubility will be increase. So on increasing the pressure on the surface of liquid at any temperature, the solubility of gas increases, which is in accordance with Henry's law. Okay, what Henry's law states: at any given temperature, the mass of the gas dissolved in fixed volume of liquid is directly proportional to the pressure of the surface of the liquid. Okay, so if it means if we increase pressure, the solubility of gases will be increases. Okay, this is the Henry law. Now today we have to discuss a new topic, that is chemical properties of water. Okay, the first property is the action towards litmus. Okay, as you know, pure water is neutral towards litmus because pure water, as you know, that purity of a substance. Okay, when a pure substance is not acidic or not basic in nature, so it neither turns red litmus to blue nor blue litmus to red. Okay, when we talk about pure water only. Okay, mainly distilled water. Then second chemical property we are looking for its stability. Okay, stability. So water is a stable compound. It does not break into its elements when heated in ordinary conditions. Okay. However, if electric current is passed through acidified water, it decomposes to give hydrogen at cathode and oxygen at anode in the ratio of 2 ratio 1 respectively by volume. Okay. When we go in your higher classes, you will be read about the extraction of metals where these mainly anode and cathode tubes are used. Okay, so water in itself is stable. Okay, it does not break into its element, but when electric current is passed, okay, when we pass an electric current in it uh, through acidified water, it means we have to add acid on it. Okay, so it decomposes, then it decomposes into hydrogen and hydroxyl ion. Okay, you can see. Okay, and this is acid which we use HCl, H plus, Cl minus. So at cathode you can see hydrogen will be receive an electron. Okay, cathode negatively charged plate. Okay, so it catches the electron and it forms hydrogen, then or it converted into hydrogen, and at anode, okay, hydroxyl ion removes one electron. Okay, and it forms H2O. Okay, by combining of 4 hydroxide ions. Okay, hydroxyl ion at that time. So this is the, you can say, breakdown of water. Okay, water only break down when electric current is passed through acidified water. Okay, either it is stable compound. Then third reaction, in many chemical reaction water act as a catalyst. Okay, water is act as a catalyst also. Okay, catalyst, many time we discussed earlier also, catalyst increase the rate of reaction. Okay, so S2 plus Cl2 in sunlight, it means moisture is means here water present. Okay, so it forms HCl. And when we talk about phosphorus pentaoxide formation, okay, so here also moisture, so it act as a catalyst here, water. Now the main reaction, which is very important for your examination purpose, that reaction with metals. Okay, so first reaction is there, reaction of cold water with sodium and potassium. When sodium or potassium is dropped into a tot of cold water, okay, it reacts explosively and forms its respective hydroxide with the liberation of hydrogen gas. Okay, if we drop sodium in water, okay, it reacts it and produce the hydrogen gas. So this reaction will be take place. Okay, one example is sodium. Okay, one is potassium. One reaction is for sodium, one reaction is for potassium. You can see easily 2Na plus 2S2, it forms 2NaOH plus S2. Okay, so when both of these metals are placed in water, they melt and form a silvery ball. If we use both, okay, in one time, so they form a silvery ball. As these metals are lighter than water, therefore they float on the surface of water and start moving in a zigzag manner. Okay, zigzag manner like this. They are floating. So tiny bubbles of hydrogen gas are evolved and the metals catch fire. Okay, they catch fire. If it is sodium, then it burns with golden yellow flame, and if it is potassium, it burns with violet or lilac coloration. The solution left behind after the reaction is soapy to touch and turns red litmus to blue, showing that it is alkaline in nature. As you know, they alkali metals. Okay, these metals are alkali, sodium, potassium. So when you, after reaction, if you just touch the solution, you feel a soapy touch. Okay, and they turns red litmus to blue because they are alkaline solution. Okay, so this is the reaction of water with metals. Okay, how it reacts with metals, so it liberates hydrogen gas, you can say in easy terms. Now we will see that water reaction with magnesium, zinc and aluminum. Remember, we are talking about the reactions of water with metals only now. Okay, we read it about, we understand about sodium and potassium. Now we read about the magnesium, zinc and aluminum. Okay, they also liberate hydrogen gas, but the water will be used in the form of steam. Okay, not liquid form of water, we use as a vapor form. Okay, in steam form. So you can see the reaction very easily. Okay, magnesium plus H2O, it forms magnesium oxide and hydrogen. Same for zinc. Okay, its oxide will be formed. Same for aluminum, its oxide formed and hydrogen will be liberated, hydrogen gas will be liberated here. Then next, reaction with iron. Okay, for iron also the same reaction, we have to take water in the form of steam. Okay, these are the reaction given. I'm showing your reaction only because it is very easy to understand that hydrogen will be liberated here and ferric oxide will be formed. Another important terms is come here, that metals present below hydrogen in the metal activity series do not displace hydrogen from water. Okay, copper, silver, gold, etc. Mercury does not react with water even under a drastic condition. Okay, in the uh, few weeks ago we already discussed about the activity series. Okay, if you don't see it, you can see the in the video of student corner. Okay, so all that, all the metals which are below the hydrogen, they cannot displace it, okay, from its solution. Examples are copper, silver, gold. Okay, in that activity series video we will discuss about it in detail, so you can see in this. Next reaction, reaction with soluble basic oxides. Okay, as you know that metals are formed basic oxides, so how water is react with their oxide. Soluble basic oxide dissolve in water to give respective soluble bases called alkalis, which turn red litmus blue. Okay, so what happen? They give their soluble bases only. Okay, basic oxide. So Na2O. Okay, sodium oxide when reactive with water, it forms sodium hydroxide. Okay, same as potassium oxide when reactive with water, it forms potassium hydroxide, and calcium oxide when reactive with the water, it forms calcium hydroxide. Okay, so they are sparingly soluble in water. They are soluble in water. Okay, then reaction of water with acidic oxides. Acidic oxide means which are formed by non-metals. Okay, so acidic oxide are also called acid anhydrides. On dissolving in water, they produce acids which turn blue litmus red. Okay, it turns blue litmus to red. So you can see first reaction here, CO2 plus H2. It forms carbonic acid. Okay, they produce acids on reactive with water. Same as SO2, sulfur dioxide reactive with water to form sulfurous acid, and sulfur trioxide will be formed sulfuric acid H2SO4. Okay, so what you have to remember that basic oxide when reactive with water, they form base, okay, alkalis or base, and which are soluble, and they are formed acids. Okay, acid oxide on dissolving with water form the acids. Now we will talk about reaction with non metals. Okay, अभी तक हमने वाटर की रिएक्शन मेटल्स के साथ देखी, अब नॉन मेटल्स के साथ देखते हैं. पहले देखते हैं कार्बन के साथ. When superheated steam is passed over white hot coke, okay, an endothermic reaction takes place with the formation of equivolume mixture of carbon monoxide and hydrogen called water gas. Okay, so whenever water react with this white hot coke, okay, it is a singular form of carbon. So white hot coke when react with steam which is superheated, okay, very much heated, it means, so CO plus H2, this combination will be formed. Okay, this combination is called water gas, CO plus H2, you have to remember. Okay, then reaction with chlorine. If you see reaction with chlorine, okay, when chlorine is passed through water in dark, it forms a greenish yellow solution called chlorine water. Okay, when chlorine water is exposed to sunlight, the following changes occur. Greenish yellow chlorine water decolorizes. First, greenish yellow chlorine will be decolorizes. A colorless and gas, odorless gas evolves, which relights the glowing splinter. Okay, so if you see the reactions, first CO plus H2O, okay, chlorine which is in greenish solution, then you further heated it, Cl2 plus H2O, okay, it diffused sunlight, it formed HCl plus hypochlorous acid. Okay, on explosion, they give the, okay, when we provide it direct sunlight, okay, oxygen will be evolved in this. So this colorless and redless gas, okay, is called oxygen here in this reaction. Then we have to test to show the color of water. Okay, you know that water is colorless. Okay, which can be tested as follows. How can you test it? First, it turns anhydrous copper sulfate from white to blue. Okay, it turns white to blue color, and it turns anhydrous cobalt chloride from blue to pink. Okay, so you can test it as follows. It turns blue to pink here and white to blue here. Okay, so it means that it is neither